Welcome to the MSJC Internet Authoring Videocast.
In this video, you will learn what a collision domain is, what a broadcast domain is, and what the differences are between the two domain types. One of the things that's important for you to understand as a LAN manager is the difference between a collision domain and a broadcast domain, and then also the fact that all devices that are part of the same collision domain and broadcast domain are part of the same network segment or subnetwork. What your objective is to simply divide the congested broadcast domains into separate broadcast domains, and then essentially what you're doing then is you're creating new subnetworks. So a reminder of collision domains: they're a collection of devices that share the same media directly. When you have devices that are connected to a hub or were arranged in a bus topology, which is a very old method of connecting our devices together, all of those devices had to listen to the media to make sure that it was clear of any signal before it could transmit. So only one device could be transmitting at any single time, and not the most efficient way to operate in a network. So that's a collision domain, and I'll give you a graphical example of that here in just a second. A broadcast domain is a collection of devices that will hear a broadcast message sent at the data link layer, regardless of the network structure. So remember that all Fs in the MAC address as the destination MAC address, if we have all Fs, that means that that's a broadcast message. And that means that all machines will receive that message and will process that message. The use of bridges and LAN switches, as opposed to hubs, as I mentioned earlier, allow a single network segment to be broken into multiple collision domains. They still remain part of the broadcast domain, but they don't have to wait individually to transmit. Here's a graphical example of that. This is representing a hub being used in a network operation. You can see the devices are all connected to the same hub here, also known as a multi-port repeater. The point really that you want to understand here, though, is that how a hub operates. A hub, if you were to actually take it apart, you would see that all those ports are basically connected like an old bus network. In other words, they are all attached to the same media internally. So if any one of these computers sends a message into the hub, regardless of the destination of that message, the message will go out, be forwarded from the hub to all computers. So that being the case, any one message being sent by any one computer ties up the network. All other computers have to wait until that message clears the network before they are allowed to transmit. So that's why what we define as a collision domain, when the devices are attached to the same media and they have to wait for each other's messages to clear the wire before they can transmit. And it's not a very efficient way of doing things. So the alternative to that then is to replace the switch with a hub, replace the hub with a switch. And a switch is still physically configured the same way as is the hub. All ports are connected to each other. But a switch uses what are called ASIC chips. That's ASIC, stands for Application Specific Integrated Circuits. And a switch also consists of a local address table, or an LAT. So every time that a computer powers up, or when we power up the switch is able to track which MAC addresses are attached to which ports. That's what goes in the LAT. The local address table. It says port 1 is this MAC address, port 2 is this MAC address. When a computer attached to that switch then goes to send a message, its message goes into the port that that sending computer is attached to, and immediately then the switch, instead of forwarding it out of all ports, the switch will refer to the local address table and compare the local address table information with the destination MAC address of the incoming message, and determine which port is the port that we should forward that message out of. So in that case, only the sending computer and the receiving computer are the ones that are affected by the transmission of the message. All other computers essentially have the ability to transmit then simultaneously. So when that's the case, as you can see by the red dashed line that we have here, each computer attached to its port on the switch, that's considered its own separate collision domain, because they don't have to wait for transmission of messages to clear all, the entire switch there before any one computer can transmit. They can transmit simultaneously because they're part of their own collision domain. So if you think about it, what a collision domain really means then is whether or not, if a device transmits a message, if there's a chance that it might collide with another message. So when we're in a hub situation, there is a chance that there'll be a collision because all the devices are using the same media, whereas with a switch, it's isolated to just the port that it's connected to, and so the chance of a collision is not going to happen. Now, a broadcast domain, which is the blue dashed line you see here, each of the computers, again, is part of its own collision domain, but they're all part of the same broadcast domain. So think of that also as a subnetwork. If we send a message that has a destination MAC address of all Fs, that's a MAC layer broadcast, then all machines will receive and process that message. Now, if you have hundreds or thousands of devices, you can understand that that would cause a problem with multiple broadcast messages from different devices occurring. That's going to generate a lot of traffic that all machines then within that particular subnetwork would need to process. So when we get to subnetting, what we're doing is we're trying to reduce the number of devices within a broadcast domain. And so that's really the goal then of your skills number 3 assignment, is to understand how to create that subnetwork. And to do that, we're going to add a router into the picture, because routers will block broadcasts. It will limit broadcasts to only one particular subnet, whereas a switch, anything attached to the switch, will be part of the same broadcast domain. And that's not exclusively true anymore. The newer switches do have a feature called VLANing, or virtual LANing, where you can actually go in through software. You can assign each port on the switch to a particular broadcast domain or subnet. So you are actually able to divide them up. We're not going to go into that kind of depth here, though, for this particular example. We're just going to assume that this is a switch that's not a manageable switch. And if it's not manageable, meaning you can't configure it using software, then anything attached to the switch will be part of the same broadcast domain. So with that said, now let's take a look at the Packet Tracer program. This is a program that Cisco puts out. This is version 3 that I'm going to show you. There's actually a newer version on the MSJC virtual machine. If you go to apps.msjc.edu and log in with the same account name that you use for logging into Blackboard, and then using your student ID as your password, once you log in, you'll get a desktop, and you'll see on that desktop is the newer version of Packet Tracer, Packet Tracer version 5. And just the problem with that is it runs kind of slow because it's in this virtual environment. And so for this video, I'm using Packet Tracer 3. It's also the one that I have posted for you on Blackboard. It's both on the lessons page. If you look under Skills 3 on the lessons page, you'll see that there's a link there that you can right-click on and download this Packet Tracer 3 program to your computer. And you'll also find it on the resources page. So if you look at the course menu there for this course in Blackboard, you'll click on resources, and then I think it's down towards the bottom of that list. You'll see the same link to Packet Tracer. You just right-click on it and save as. You choose save target as, save it to your computer, and once it's saved to your computer, you just double-click on it. It's just an executable file, and it's a fairly small file. It's not going to take a long time to download, so there's no installation required. It's just a real simple program. And so anyway, you just double-click on it, and it opens up to the screen that you see now. And it's pretty easy to make this thing happen, make it work. Let's start by doing the demonstration. We just talked about collision domains and broadcast domains, so let's create a collision domain. Let's take this hub here. I'm going to click and drag it into our work area, and then click to place it in that work area. and then we'll attach some PCs to it. So I click on the PC here and then move my mouse down and click again. So just each time I'm clicking back on the PC and then clicking in the work area to place it there. And you can see that the program automatically numbers them for us: PC0, PC1, PC2. Now we need to connect them, so we've got this little connector icon. We click on that, click where we're starting from, where we're going to, then we have to go back to the connector icon, click, click, and then one more time, click on PC2 here, and then click on the hub to make the connection. So they're all physically connected now. We have a local area network here. We have our collision domain set up, which is also, of course, our broadcast domain. And the only thing that you do need to do additionally to make this process work is you do have to assign the network layer information. So we're going to double click on PC0 here, which gets to its configuration dialog box. And in here what we need to do is we need to give it an IP address. So since this is system 0, I'm just going to put in 192.168.1.10, and then you just close it up. Oh, actually, we've got to put the subnet mask in on this one too. The newer program's nice. As soon as you tab out of typing in the IP, you just press tab. It'll automatically put in the subnet mask for you. Okay, so I've got 192.168.1 is the subnetwork address. Because that is the subnetwork address, we use 3 255s, right? So we're saying that the first octet, second octet, third octet is the subnetwork, and then we're saying that last octet is the individual host value that uniquely identifies that system on our network here. So then we just close that up, and we'll just go through the same process here on PC1. And the numbering scheme I'm using here, you'll see, is going to be the same subnetwork. That's very important, right? All computers that are going to communicate within the same subnet have to have the same subnetwork address. So 192.168.1, and then this one will make it 11. Since I made the other one 10, what I'm doing is I'm just adding 10 to the number that was assigned by the packet tracer program. Just makes it easier to keep track of things that way. So again, same subnetwork address, different host address, same subnet mask. All these computers will be using the same subnet mask. We don't need a gateway here. We only have a single network. We're not trying to go off of our network, which is what the gateway is used for. And then our last one, 192.168.1.12. And again, the mask is the same, 255.255.255.0. And we go ahead and give it a click. Actually, before I click, just let me show you a few things about this. You can turn the ports on and off through the configuration. See how the dots went red when I clicked on the off button. You can change the speed at which you're operating. This particular program only supports 10 megabits and 100 megabits per second. The new program also supports gigabit networks, and it has a lot of new connection types. It's got fiber and some pretty interesting options for you there. Auto negotiate's the best thing to choose here. That's pretty standard in all devices these days. Most network interfaces have an auto negotiate feature, which means that they're capable of identifying the speed of the network that they're attached to. Same thing with duplexing. Pretty much everything's full duplex these days, but we'll leave it at auto negotiate. You know, these settings are just to make your demonstration here, your simulation, a little bit simpler to configure. And notice it does assign a MAC address to all of these computers as well. Okay, so I close up PC2 here. We've given an IP address and a subnet mask to each of our 3 PCs. That's the configuration, so we set that up here in this topology tab. Now we click on the simulation tab. And in the simulation tab, what you do is you actually assign a message from one device and identify where you want that message to go to. So here's the little message icon. I click on it. We come down and put it on whatever PC. We just click on the PC we want to be the sending device. And then we click on the PC that we want to be the receiving device. So we've said we want the message to go from PC0 to PC2. And remember, we're attached to a hub here. So now when I click on the play button, what you're going to see is the message is sent to the hub. But notice the hub, let's go back and do that again. The hub forwards it out all ports, PC1 ignores it because PC1 looks at the destination MAC and says, oh, that's not me, and discards it. But that's the important thing about a hub. In fact, you know what? I'll go back to my topology here. Let's add just a couple more PCs real quick, just to really emphasize this point here, that they're all part of the same collision domain, meaning that when we send a message into the hub, that message is forwarded out of the hub, out of all ports to all devices. So let's configure this one as 192.168.1.13. Put on our mask, same mask as always. In this case, they're all part of the same subnetwork, so they'll all use the same mask. And 192.168.1.14. And subnet mask. Okay. So back to our simulation again. We'll go ahead and run that same simulation now. And notice here, all ports transmit forward that message. Let's go back to it again. Notice this is the far left button says start at the beginning, whereas this is a step backwards, just kind of like a VCR. For those of you that remember VCRs, I guess we have that in DVD players too, don't we? Okay, so I just want you to really understand here. I send the message into the hub, and the hub relays that message out, which realize that message, in this case, we're using copper wiring here, so that message is an electrical signal that is being transmitted out of all ports, and it happens, within milliseconds. And so that's what's making them all part of the same collision domain, in addition to the fact that they are all part of the same broadcast domain. Okay, now let's change this scenario. Let's go back to topology. What we'll do is we'll take the links that we have here of the hub and remove them all. So what I did is I just double-clicked on the hub. Actually, I take that back. It's a single click. Single click on the hub. And you can see here's the ports that are occupied. So you select the port, click remove, select, remove, select, remove, select, remove. And we're just getting rid of all the connections there that we have to that hub. And we'll just drag this hub out of the way for the moment. Now let's go over here and get a switch and put it into the place of the hub. Reestablish our connections. Now the network interfaces on the PCs remains configured the same, so they have the same IP addresses. That doesn't change. All we're doing is changing the device that is its central concentrator here. That actually is what defines our subnetwork. Anything connected to the switch is still part of the same subnetwork or broadcast domain. But now let's see if they're part of the same collision domain. Same scenario, PC0 going to send over here to PC2. When we click on the play button, now you'll notice that message is only forwarded to PC2. It doesn't go out all ports to PC3, PC1, PC4 there. So that means that each of these devices is part of its own collision domain. And remember that your objective here in Skills 3 is to set up a subnetwork, and so I'll be able to demonstrate that too. In fact, you know what, actually before I go there, just because this is a little quicker, let's set up our subnetworking at this point in time. Let's add a router now into the picture here. The key of a router is that this is a layer 3 device, and that's something that's really important for you as a LAN manager to keep in your head, so make a note of this. A hub is a physical layer device, because all a hub does is receive the input signal and forward it. So in most cases when we're dealing with hubs, we're looking at a electrical device, right? So it receives the electrical signal, the electrical digital signal, and retimes it, regenerates it, and forwards it out all of the ports. So it's a physical layer device. A switch is actually capable of reading the MAC layer addressing information. Remember, I talked about the fact that a switch has a local address table, and it knows which port number is connected to which MAC address. The way that it knows that is because a switch actually reads the MAC layer header of the messages that are coming in, and that's how it determines that a particular MAC address is attached to a particular port. So it looks at the source address as the messages come in. It says, oh, that's coming, PC3 is Mac XYZ, and that's on port 2 or 1 or whatever it is there. And so that's what it puts in its local address table. So a switch is a layer 2 device, a data link layer device, because it's capable of reading and processing MAC address, or MAC headers in the messages. Whereas a router is a layer 3 device because it's capable of reading the network layer information, which is, in the case of a TCP/IP network, that's the IP address that's coming in that port. So the router will limit MAC layer broadcasts. Any device attached to this switch, and we'll attach this switch now to the router, all of these devices are part of the same broadcast address, so they will receive, all of these devices will receive a broadcast, MAC layer broadcast message. But now I'm going to add some devices on the other side of this switch. So I mean the router. So on the other side of this router, I'm going to add a switch. Right? We need to have a central concentrator, which is the switch to attach all of our PCs to. So let's put a few more PCs into the network. And now we're going to actually have 2 sub-networks. And the router is the defining element here, the defining device as far as creating this configuration as 2 sub-networks. So a switch basically is creating a local segment. Anything attached to it's the same broadcast domain. So we have 2 broadcast domains now, one above the router, one below the router. So we have 2 sub-networks created because the router blocks broadcast messages. Anything from this top sub-network, if it's broadcast at the MAC layer, router won't forward it. Anything that's broadcast at the MAC layer from this bottom sub-network, router won't forward it. And so as you can see, hopefully right away, that's how we can help reduce congestion in large networks, is by separating them out into sub-networks. And of course they become like administrative units as well, which works nicely. So we have to configure our devices here, and this is a real important aspect of what you'll be doing in your skills number 3 here, so pay close attention to this. If you recall, on our first network that we created, we assigned 192.168.1 as the sub-network address. So since this interface here is attached to the router's interface, so it's connected to the switch, which remember that defines our sub-network, and then it's connected to this interface on the router here. That means that it needs to have the same sub-network address. They must match. Everything on the same every interface connected to a sub-network must use the same sub-network address. So I'm using the first 3 numbers. That's our sub-network address, 192.168.1. And in this case, this is pretty common. I'm going to make my router's interface .1. So it's the first interface on the subnetwork. It's just that way, as an administrator, it's easy to keep track of router interfaces. Instantly, if you see a .1 address, you know that that's a router interface. We have 2 interfaces, right? We've got the 0, and notice that too, that when we're talking about interfaces on devices, the very first interface is always numbered 0. That's just because that's the way binary numbering works. Everything starts at 0. So the second interface is this one here. I'll click on it. Now you notice the IP and subnet disappears because we're configuring a different interface, right? So on 1 now, 1 is attached to my network down here at the bottom. We're going to come up with a new subnetwork address. We're going to make it 192.168.2. That's the new subnetwork address. And then again, I'll make it 1 as the unique host value on that subnetwork. Mask will remain the same. All we're saying is look at the first 3 octets. That's your subnetwork address. And the remaining octet is just the unique host value. Okay, so once we've done that, then we're going to go into each PC and go ahead and configure them. 192.168.2, and we'll make that .15, keeping with my previous numbering scheme. We could have made it 5, you know, I mean, it's not that critical. It's as long as it's on the same subnet and it's unique to its subnet. That's the 2 key elements there. 192.168, oops, typo, .2, .16, 255, 255.255.255.0. And you'll notice too, we don't give the switch an IP address because a switch is not a layer 3 device. Right? It's a MAC layer device. So it has the ability again to process MAC addresses, but it doesn't have the ability to process the IP or network layer headers. Okay, one last PC here and we'll have the basic configuration done. Okay, no, subnet mask. See, it told me that. Oh, I put in the wrong one, didn't I? Put in 17 when it's 18. There we go. Okay. Now, let's see if we can send a message from PC6 up to PC1. Let's go to our simulation. And let's click on our message icon. Click on PC6. Click on PC1. And instantly, you see we get a red icon here and an X down here on PC6. And the reason is that's telling us that our configuration isn't quite correct here yet. So let's go back to topology and I'll show you why that is. Remember earlier I told you we only had a single network, so we didn't have to worry about gateway addresses. But now, when we want to go from one subnetwork to another subnetwork, we need to have a gateway address on each of these devices to tell it where to forward any messages that go from this LAN to the other LAN, to the other subnetwork. So that gateway address is the IP address of this interface that's attached to our subnetwork. So these devices all need to use this top interface, the 0 interface on the router for its gateway, and all of these devices on the bottom network, they need to use that one port on the router because that's the one that's attached to that particular subnetwork. So we need to go through here now, and for gateway, we're going to put in 192.168.1.1 on all of the top devices. Now we're going to go down to the bottom devices, and what do you think is going to be the gateway address there? 1? No, 2.1. So on the 2 subnetwork, and then the first device on that network. And it's not always 1. I mean, you have to know what the actual IP address is of this port. So just to go back here to port 1, this is what I'm putting in as the gateway address here of all these computers on the bottom. And I'm just in the habit of typing in 1, but it's got to be a 2.1. Okay, so now we've got all of our devices on both sides, both subnets, configured with their default gateway. Also, then, if I look at this closely, I realize I've not put the right addresses on my router here. Here's port 4 actually is the top port, the top interface on the router, and port 0 is the bottom interface here. So I need to go back and reconfigure that. So port 0 we've got as the .1 subnet. That's not correct, right? It's the bottom subnet, so it's actually .2. So that will correct that. And then the 1 network actually, well, let me change it because I have that on the other interface. Let's put this back to, let's make it 3 for the moment, just so that I can go back. I've got to delete this one completely because we're not even using the 1 interface. We're actually using the 4 interface. See little green lights here? You got to pay attention to detail. So we'll go back and configure 0 as 2.1. So again, that's the bottom network, 2.1. Now we'll go back to 4, and we're going to plug in the right address there, which is 192.168.1.1. So 4 is on the 1 subnet, and 0 is on the 2 subnet. Okay, so now let's go to the simulation. Let's take our message here, and that remains the same, so that should work now. Let's see if we can get it to work. Click on the play button. They both go to their switch. We crashed at the router here. Why did we crash at the router? We've got 4 up. 4, oh, I didn't have a mask, obviously. Look at when I rest my mouse over it tells me my configuration on the router. And you see there's a CIDR value for the port 0/24, but for port 4, you see that there's no CIDR value. So what that tells me is I didn't put in the subnet mask. Means I wasn't paying attention. Yeah, that's exactly what it was. So we'll go back and put in the right information there in our topology tab is where you do your configuration. All right, now let's go back to our simulation. And we're at the beginning, so we'll go ahead and run it. Goes to the router, gets forwarded to the next subnetwork, and then gets to its destination. Let me just kind of summarize what you've seen here. I want to make or emphasize the fact that each of these switches establishes their own subnet, and routers separate those two subnets. So when we separate subnets, you have to change the IP information, the network layer addressing information, so that the router and its interfaces are able to determine that they are attached to different subnetworks. And so the key there is to always make sure that the octets that represent the subnetworks are different for both of the subnetworks, and then the devices that are on those subnetworks, their octets that represent the subnetwork must all match, and of course they should match with what the octets on the router are configured as far as the subnetwork address as well. Other than that, just every device has to have its own unique host value. So I gave you a real simple scenario there using 3 octets to represent the subnetwork information and the last octet to represent the host. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.